Hi scholars, it's Miss Marnon. So today we're going to be working on Unit 4, page 7, quantity equals percent times whole. So our objective today is we want to make an equation and use it to help us with any percent problem. Then we don't have to think about, do we multiply, do we divide? We'll just always use the same equation, and I'm going to show us how that works today. But first we have our DIN. So our review question. This year Braylee is 12 years old. So let me get out my pen so I can start circling numbers. Her brother Braden's age is 175% of her age. How old is Braden? So pause the video and see if you can figure this out. Okay, so if you want 175% of Braylee's age, that means compared to her, she is the whole that we're starting with. So we can just multiply these. When they give us the whole, we can multiply. So we can do 12 times 175%. If you have a TI-34 calculator, you can just type that in. Is that exactly how you see it? If you don't have the TI-34, we need to change this percent to a decimal. So if I have 175%, the decimal would be right there. We're going to have to move it 2 over to the left, and it's going to be 1.75 as a decimal. So we can do on any calculator 12 times 1.75, and we'll get our answer. So let's open up our Desmos calculator. So if you don't have it open already, should be bookmarked here. We need 12 times 1.75, and we get 21. If you are using the Desmos calculator, the other way you can do it is we know we want 175% of 12. So either way will work on this calculator. We just need to show our work. And we got 21. So we can say he is 21 years old. So for our preview question, what operation did we use when we had the whole? What operation did we use when we needed to find the whole? So pause the video and answer these two questions. Okay, so here's what we had right here. We had the whole, so we multiplied. And here we needed to find the whole, so we divided. For this next one, we got to think about a nickel. So a nickel and a dollar. So when we think about a nickel, how would we write that? A nickel is worth 5 cents. So we would write it as 0.05. And we would write a dollar as 1.00. A nickel is 5 cents. A dollar is 100 cents. So this is 5 out of 100. A dollar is 100 out of 100. Or a nickel is 5% and a dollar is 100%. So here's something else we're going to look at. So that was just kind of a quick showing us nickels to dollars. But I want to talk about this. 25% of 12 is. We've done percents of wholes right here. We can type 25% of 12 right on here. And we actually get 3. So we know it's 3. So now we have a couple parts to identify. What is the part? So what is that part of the whole? It's going to be 3. And then our whole is that 12. So there's always this way we can use this equation, and maybe you saw it in the title or when I said it. We're going to be using quantity equals percent times whole. Now I know we didn't list anything for quantity above, but here's what I want to talk about real quick. Yesterday, well not yesterday, on Tuesday, we did a lesson that was about percents greater than 100. So when we had a percent greater than 100, like Braden's age here, he's not a part of Braylee's age, right? Because he's actually older. He was 21 we got. So it's not a part, it's like a quantity of how old Braylee was. So we can replace the word part with quantity. So I'm just going to put a note to self here. We're going to replace anytime we say part with quantity. Just because we do have times when we're looking for a quantity, that is actually bigger than the whole. It's not a part of the whole, just like we had in our review question here. I wouldn't say Braden's age is a part of Braylee's age. If he's 21, it's a quantity of. So we're just comparing it to. So there's always this equation we can use. So if I wanted to try it with this 25% of 12 is 3, our quantity is 3 and our whole is 12 and our percent is 25. So if I want 25% of 12, this is my whole, this is my percent. So we just need quantity equals percent times whole. So quantity is what we don't have equals the percent we know is 25% times the whole is 12. So if we do this, we can see it's multiplying. It says percent times whole. We always do the percent times the whole. We didn't really have to think about it. We just need to remember this equation and it will tell us to multiply the percents. So we multiply 25% times 12 or 0.25 times 12. We will get 3. So let's look at exercise 2. So for exercise 2, we need to identify the part, percent, and whole. This one, it is a part, but if you wanted to replace this with quantity to be more accurate, that would be even better. So we have to read each problem and fill in the table to record what we know. So 40% of students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? So the percent's the easy one to identify because it's got the percent sign right next to it. So we do know we need 40%. Here, we have that. This 20, we just need to decide if it's the whole or the quantity. So if it's 20 students on the field trip, that's 20 students total on the field trip. That's not how many just love the museum. That's how many total on the field trip. That's going to be a whole. So this quantity, this part, is what we don't know. So let's look at this next one. 40% of the students on the field trip love the museum. If 20 students love the museum, how many are on the field trip? So again, we have that 40%. It's easy for us to identify. It's just this 20 we need to decide. If 20 students love the museum, how many are on the field trip? So we're just talking about a part of those students that love the museum compared to everybody on the field trip. So the students who love the museum are just a quantity or a part of it. And this is what we don't know. We don't know how many students are on the field trip. So this third one, 20 students on the field trip love the museum. If there are 40 students on the field trip, what percent love the museum? So we have that 40 students total on the trip. That's going to be our whole. And then the 20 students that love the museum is our part or a quantity of that whole. And it's actually this percent that we don't know. So this was just practicing identifying. If you go through and figure out what each of these numbers are using our formula quantity equals percent times whole, you'll get extra credit for that. But let's look at exercise 3. We're going to actually solve some of these problems for exercise 3. So in Jenny's math class, 20% of students earned an A on a test. If there were 30 students in the class, how many got an A? So we clearly have our percent here. We need to know if this is our quantity or our whole. So we're talking about some of them earned an A, and then everybody in the class. Everybody in the class is going to be our whole, and how many students earned an A is going to be our quantity. So we just need to set this up. It's quantity equals percent times whole. And so I'm just going to do Q equals percent times W. And now we're just going to substitute in the values that we have. So our quantity we don't know, so I'm going to just leave that as a Q. Our percent, we have 20% times our whole, which is 30. So this is something we've been doing. We know how to multiply percent times a number. We need to change this to a decimal if we don't have a TI-34 calculator. So we're going to rewrite this as, move that decimal over, 0.20 times 30. So let's type that on our calculator. So we have 0.20 times 30. I got 6. So that means 6 students got an A. Number 2, in Jenny's art class, 12% of the Flag Day art projects received a perfect score. 25 art projects. There were 25 art projects turned in by Jenny's class. How many of the art projects earned a perfect score? So we have, again, here's 25 projects turned in. Some of them got a perfect score. So the projects turned in is what we're comparing to. This is going to be our whole. And then the perfect score ones are going to be our quantity. So this one's going to be set up the same way. So why don't you pause this video and see if you can get this answer. Okay, so this is going to be quantity equals percent times whole. Our quantity is what we don't know. We do know we have 12% times the 25 students who turned in their art projects. So we need to change this percent to a decimal if we're not using a TI-34. So this would be 0.12 times 25. Let's type it on our calculator. 0.12 times 25. I got 3. So that is 3 art projects earned a perfect score. Last one, and I'll do this one in purple. In Jenny's English class, 70% of the students completed an essay by the due date. There are 30 students in Jenny's English class. How many completed the essay by the due date? So quantity equals percent times whole. Here we have our percent. 30 is the total in the class. So that's going to be our whole. And how many completed it by the due date is going to be our quantity. So pause this video and see if you can solve this one. Okay, so we have quantity equals percent times whole. The quantity is the part we are missing. We have 70% times our whole class, which is 30. So we can do this as 0.70 times 30. Let's type it on our calculator. 0.70 times 30, and we get 21. So we have 21 students completed the essay by the due date. Completed essay by the due date. Okay, so these were all finding the quantity. I just want to show you with this museum one what we need to do if you need to find the whole, because that's something different. And it's also going to be the same kind of method for finding the percent a little bit. But so here's the thing. We did one-step equations in 6th grade. We had things that would look like 3 equals 2x, and you would know how to find x. So that's going to be something similar to what we're going to do right now. So if I want to find the whole, this is the quantity equals percent times whole. So I'm going to do this one. So we have quantity equals percent times our whole. I know my quantity is 20. I know we have 40%. And I know that our whole is just going to be W. Let's rewrite this so that percent is a decimal. Now, in 6th grade, you guys learned about how to do the opposite operation to get a number by itself. So you guys know if I do 2 divided by 2, I just get 1. But we also know that an equation is balanced. So I can't just do one thing to one side. Like if I had 3 markers in each hand, I can't get rid of 2 markers in one hand and then say these are still equal. So if I get rid of 2 markers in this hand, I need to get rid of 2 markers in this hand. And we'll talk more about this in our upcoming units about equations, but this is a review from 6th grade, how to solve things like this, so we should be able to do this. So if this is times 0.40, we need to do the opposite to get rid of it. So we would need to divide by 0.40. So now what happens is on this side, a number over itself like that we know is 1. 5 over 5 is 1. 100 over 100 is 1. 3 over 3 is 1. 0.40 over 0.40 is 1. But because I made a change on this side, and because this is equal, we need to do the same thing on this side. So what's going to happen is this is going to go to 1, and 1 times anything. So 1 times W is going to just stay W. And then we have 20 divided by 0.40. So 20 divided by 0.40, we get 50. So this is saying that 50 is equal to our whole. Let's see if this makes sense. We're saying that 40% of the students love the museum, 20 love the museum. Does 50 make sense for a total to be on the field trip? It's bigger than 20. That makes sense. If only 40% on the field trip loved it, that means there has to be more than 20 on at the museum to get the whole. We can also see this using a double number line. So if I want this to be students, and I want this to be percent, we have that 40% is 20 students. We wanted to know what 100 is. So this is another strategy you could have done to figure it out. We could have broken this up because 40 and 40 would only get us to 80. So we really would have need to broken this up into 20%, 40%, 60%, 80%, 100%. Figure out what all these values are in between. So half of 20, this would be 10. So this is going to count by 10. So 10, 20, 30, 40, and we get 50. So that's just another strategy we can use, but it does take more time than solving the equation. So that are the notes for today, and some more extra. You have 2 practice questions. They do have multiple parts, but it'll take you not as long because like some of these questions, which is the whole? And these are actually related about kind of the same thing. Then you have an exit ticket about how many students were surveyed. If 60% said they preferred Takis to hot Cheetos, if 500 students were surveyed, 500 students surveyed preferred Takis. So 540 like Takis, how many total were surveyed? So you have these practice problems, your exit ticket, and when you're done, you're going to log on to Delta Math and you're going to complete practice. This says 2, it's really 3.